Okay, so now let's do a few trinomials where there's some common factors. So you'll notice that this first one has a common factor of 4. So let's factor that out first. That's going to give us v squared minus v minus 2. Now, when you're factoring like this, make sure that whatever factor you've made isn't factorable further. In this case, it actually is, right? So let's say this is a 1 and this is a negative 2. So we can check, okay, it's v times v, and negative 2 could be, let's say, 1 times negative 2. You can check that and see 1v minus 2v really is negative 1v, so this one is correct. So that's fully factored. Now, a lot of students, when they look at this, may miss the common factor. And if you miss the common factor, I want to show you that not all hope is lost, but it is very annoying to get it fully factored. Because when you do this, there's suddenly so many more choices to test, right? If you're really starting with 4 and negative 8, you have 1 and 4, 2 and 2 for 4. You have 1 and 8, 2 and 4 for negative 8. But then you have all these ways that the minus signs could be arranged. And then you have to also consider that maybe if you tried the first time it doesn't work, you have to switch it around. So let's say that you try a bunch of these and you come across the correct factorization for v and v, and what was I doing? Yes, 4v times v and 4 times negative 2. If you check it, this does become your original trinomial. You have 4v minus 8v, which is negative 4v. But this is not fully factored because you can still check this one for a common factor, which is 4. So ultimately you do get the same result, but because you have so many more possibilities when you're checking all the ways that the 4 and negative 8 can combine, it's not recommended. So you really should always common factor first to reduce the possibilities. Okay, let's do the next example. So we have 12h squared minus 27hk plus 15k squared. Again, we're going to check for common factors first, always, every single time. 12, 27, and 15 are all divisible by 3, so we can take that out. And there's nothing else left, so let's figure out what we have left. We have 4h squared minus 9hk plus 5k squared. So you can see this resulting trinomial has a and c being 4 and 5. That's much easier to work with than 12 and 15, which is if you didn't see that common factor. So now let's see what we can do. So 4 could be 1 and 4, 2 and 2. 5 could be 1 and 5, and that's it. If we try, for example, 4 and 1, and then maybe 5 and 1, you'll notice that this is almost correct. So we have 5k times h, which is 5hk, and we have 4hk, which is 9hk. That's positive 9hk, which is the same but just the wrong sign. So again, we're going to remember that to make a positive 5, you could also have two negative factors, negative 1 and negative 5. So if we switch that around, we're going to get negative 5hk and negative 4hk, and that is correct. So that's our final factorization.